now they're going to go back and ask the Oracle, okay, why didn't this work? What's happening? I mean, we bought into your dream of all this investment in automation. We hired these guys, you know, and we've been giving them whatever they wanted, and still we have no results here. All right, so now to understand what really happens, let's just backtrack a little bit, where we said we just hire some people, they do some automation, and we're supposed to see some results. And let's backtrack and see what actually happens, right? So the problem, or the objective of automation, was to solve the testing problem. They had problem with testers. Now, what's that problem? So as we start developing our product, you have one feature, you add more features, we add more features, and as features keep getting added, the amount of tests you have to do keep getting added, of course, right? And of course, we know the story. Eventually, this becomes an infinite thing, and there's just so much to test. And of course, we have very limited resources. We cannot test everything. So this was the core problem that we wanted to solve, right? So this core problem created increase in time to market. We need more people, and cost goes up. Because our cost and time are constrained, the quality gets constrained. So all of this is eventually going to have that effect of those three parameters giving us trouble. In a typical scenario, you have a tester. He starts off okay with his regression cycle. They start doing something, and more than often you don't get enough time. You know, you bargain for 2 weeks of regression. I think we've all been there. And eventually you get half a week or 3 days or 1 day if you're lucky. And then you barely go through some basic functionality, and that's it. You don't have any time. So from the tester's perspective, there's just of course, we always feel there is so much to test. Sorry if you keep seeing me here, because I keep getting pings about people to admit. So I'm trying to admit them at the same time. So there's so much to test. And as testers, most of the time, we don't get time to think and strategize as to what we are supposed to focus on, what's important, what's not important, try to think about where the risks might be. And we barely go through just the basic functionality, and then that's just it. So of course, as a tester, I won't be able to have any say into how much time or what's the quality of this product, because I'm not able to do my job. So after automation was added, come in, now what happens? So of course, management hears this cry of let's get started with automation. And okay, so this is okay, what to automate and how to automate. Do we have any plan or strategy? Everything has to be automated, because automation is going to solve everything. So let's just automate as much as we can. So automate testing. So that's where we begin. Then you hire an automation guy and you ask him, okay, what to automate? And usually the answer is complete regression. Anything that these guys do on regression, whenever I ask them, okay, I have to release something, they come back to me saying, we need X time, we have such features in the past we weren't able to do. Instead of all of this happening, just all of this regression thing, I can, just done, I can release it. So the manual tester asks, the automation guy asks, I need some test scenarios, what to automate, because of course I am an automation expert. I'm not a domain expert. I don't know what you need automation for. So just give me what test to automate. And usually testers will have a pack or test cases, which is usually the complete set of tests that they have done since inception. So if a project has been running for 10 years, all the tests they have written for 10 years is part of that big humongous regression pack. We hardly get time to go back and clean that thing. A lot of things are redundant. They're not the functionality anymore, but that's what my regression pack is. All right. And the automation guy is just so excited about this, right? Okay, let's just do it. I got my regression test, and I'm going to prove by doing a lot of automation here that, we're going to get cracking on this. So do you need, and the tester, of course, because his problem, again, that big testing problem, right? So do we want any sequence in which to automate the tests? How do you want me to go about doing this? I mean, so as automation guy, again, I'm not interested in picking up as to what priority. That's all your job. You just give me what to automate and I'll automate it, and that's the end of it, right? Because that's what they're hired for. So a few months later, of course, the start off, the automation guy starts off with some automation, and more than often they start automating at the wrong place, which is what we are going to talk about today. And in between, because they automate at the wrong place, they're not really automating what's important. They just start on automating with whatever test cases we get, and most of the time, not all of them are reliable. You have a lot of flaky tests. So even if you run all of them, like 30%, 20% of them fail, and that's usually the average. So, and then later on we realize, geez, this automation business was hard work. I mean, we spent all this time, and even then, whatever variables they are, things keep changing, requirements keep changing, my scripts keep failing, Chrome drivers changed, this changed, application changed, new features coming in. There's a lot of hard work, and it's not reliable. And at the end of it, from a tester's point of view, they spend a lot of time, in some cases less or more, trying to test all they have to do. Automation is not able to cover much because they put in a lot of effort, but they didn't cover a lot of ground. As a tester, I still have a lot of testing to do. And everyone, the automation guy, probably some of the tester might have spent some time learning, and still automation is not helping us. So eventually everyone feels that this automation is just a drain on our time and it's not really helping me, right? So we talk about what is the real purpose of automation then. Why did we go through all of this pain and what went wrong? So the team goes back to the oracle and asks them, okay, so did you just want us to be miserable, to go through all of this, and eventually we don't reach any conclusion? What do we want to achieve here? So the problem that we started off with was where we have a lot of test scenarios to cover and we have limited resources, right? That was the root cause of all of this. So, and as a tester, we said only if we had more time and resources. So now let's talk about, to test, there are three main, when we say we are testing, there are three different areas that we have to focus on for testing, right? The first is thinking and strategizing. You think about, you talk to what the requirements are, what kind of solution we are building, you explore the solution, and then once you have a sketch in your mind, then you go about checking whatever scenarios you want to check. Let's talk about these in detail. So thinking and strategizing, of course, it's more about collaborating with people, talking to your business owners, to the developers and testers, having a three amigo session, writing some feature files. So all of this, of course, requires understanding what has to be done, and for that, that portion cannot be automated. Then you have exploring the application, trying different variations, checking things at the back end, changing things. You try to identify risks. Once you've done all of this homework, then you have time to, okay, now I have a set of tests which I've tried a couple of times and these make sense to me. Now I want to try and automate these. So you see, when we say we are trying to automate testing, it's really important to understand which portion of these are we trying to automate. It's just this black box checking is which we are automating. This rest of this has to go on, right? So plan what to test, where to test, understand problem to solve. A lot of times teams, we just get a feature, probably a screenshot of an non-functional prototype or a one-liner story, and we just start trying to test or trying to develop. Purpose of that feature is to solve a real-time business problem. There is an actual problem in the field which someone wants to get solved. Now, unless you don't know what that core problem is and you try to test something, you won't be able to validate as to if this solution is working or not. You first need to understand what the core problem is. And that is one of the biggest places where testers miss, because we're in this firefight mode all the time and we don't really get time to talk about what the core problem is. Then, of course, you talked about exploration, you question the requirements, clarify assumptions, and you do your exploratory testing. And the last one is checking, which we say we want to automate. So, about the next thing is about regression. So, we have a total list of scenarios, the gray ones, a lot of scenarios we want to test. Now, out of these, what is considered regression is not your complete set of all tests that were written since inception. That is not regression. Regression is usually the important tests which are absolutely critical for the application to work or function properly. For instance, if feature A fails, that is going to be a showstopper coming back, and we'll have to do a hot fix or something for this one. So that's an important test, and that should be part of your regression. If you have a test checking for some colors or fonts or so, that should not be part of your regression. But then you want to prioritize your tests. The problem most of us have is we have this massive tests. First we spend time writing them, then we spend time maintaining them, different types of OS, and then we try to automate them all, and that takes just too much time. Automation is for testers. That's the objective. If your automation exercise is not really helping your testers, there's no point automating whatsoever. That is the mistake most of us make. Testers are in a separate silo trying to cook up something, and is in a separate silo trying to do something. Because of all of this, is we are not really adding value to the test. If we don't add value to them, effort does not decrease, remains. So I've the story part, and I want to put more time here on how to automate properly, because this is the crux. So first, before we start automating, we need to have some ground rules, right, as to some criteria. Okay, so as a tester, from automation does not start from deciding your automation framework. We do. Automation does not start with what language I'm going to use. It starts with fixing your testing first. Thing is, then your automation is automatically going to be inadequate. Testing or automating the right thing. Automation, you have to start fixing testing first. And a lot of teams that I have worked with, when we start transforming teams, we get is not about, yeah, automation frameworks are a big issue. The bigger one is fixing their testing. I think they have a problem. They all think, yeah, my testing is fine. I have a problem with automation. What I am automating is all rubbish. You have the right strategy what to test first. I'll subject very briefly. So for a test strategy, first you need to think about what to test. Talk about where to test, and then you talk about how to test. About what to test. So I'll explain that later, but right now I'll just give 3 points. Find out the core problem, design. That is the first step. So to have successful automation, the first step is you need to understand what is the core problem your feature or product is trying to solve. If we have a new feature saying, okay, I have a shopping website, let's say Amazon.com, new feature saying, which says at the top, at what is your total bill amount? It shows you right up there. What is the core problem we're trying to solve? Reduce, let's say, one click of the user instead of them going back and forth, always checking the cart, how many, what is my total bill. They can see it right there and then, so that convenient for them to know, okay, what is my total purchase at this point. That's the core problem. So you need to understand the problem of business. A lot of times we develop something really helping out business at the end. As testers, to know what the client wants, it really doesn't help us. So that's core problem. Your solution design. Solution design happens a lot of times only when the feature is developed and it's smart as ready for QA or something. We start. The problem by that time, the design of how that feature was to be developed, the architecture, how the communication was supposed to work, which piece is being implemented at which point in the architecture, front end, back end, where all of that has been decided and it's done. Happens then, we are trying to probe into the application from the outside. Essentially, what should really happen, what we try to advocate teams, architectural discussions are happening, the design discussions are happening. At that point, you think about testing. Your feature should be testable. For instance, quick example. For our example again, where we said we want the total purchase cost in on the shopping cart, UI element, right? So you should have API calls. So when your API call is being developed, you might want to, as a developer, this should be a separate JSON in your JSON schema. There should be a separate field somewhere, and we are going to validate this field. And on the UI, if you want, okay, so for this element, I need to have a specific user ID, a specific object ID, and I want to check this ID. Supposed to happen at the solution design level when these things are being decided, not when it's done and dusted. The next one is risk analysis. This is the exploration part. I really recommend looking at James Back risk analysis. He has a white paper on this, and it's very good. Most recommend teams doing that. He talks about outside in and inside out risk analysis. In analysis is where we say, okay, I as an exploratory tester, I'm trying to approach the application from an outside user's perspective. That's outside in. Inside out is where most of our effort should go. We're lacking. Is what I talked about earlier, looking at the design of the code or the code itself, figuring out from the inside, okay, if I change this control flow, then what's going to happen? In our shopping cart website thing, where with the example we just gave, a function in the business logic which is written at the back end, probably I might want to sit with the developer how this business logic has been developed at the back end. So it will be function passing values to function, reading from the database, coming back, doing some logic and sending it forward. So between these functions and these communication, how that is happening, have a whiteboard session on that. Walk through with the developer testers sit together and walk through that feature, how that works. You will find a lot of issues. Finally, the last point, which a lot of these came from the key elements of this test strategy. A while ago I designed this. I'll put this in the links somewhere, so you guys can access this. It's in to zoom enough. Well, I'll try to give you an overview. So you want to know your quality vision as to what you're trying to automate. We talked about your product's objectives. So you have your test objectives, right? How you want to measure stuff. So this is a very comprehensive one. Probably not all of these might be applicable at the enterprise level. But we are specifically talking about these in the exploratory guidelines. Exploratory testing guidelines, testing at the lower levels of the tech stack, which is what we talked about, inside out risk analysis, how to document and maintain tasks, how to add regression tests. So at this point, we're trying to answer what to test. Next should come the helping document to figure out what to test, right? And this is a sample, but a sample one you can pick and choose what you want. I'll share the link with you guys. All right, now where to automate? We talked about what to automate, exploratory test. I know what are the risks of my application. From a user's perspective, I know the risks. Now I'm going to talk about right. So this many times, probably some of you might have heard it before. So this is the infamous automation pyramid. You see, the reason why they designed this pyramid is, and this was given by Mike Cohen back in 2007, that a lot of the code is written at the back end and very minimal written on the front end. So you see your complex business logic, all the complexity, all of it is at the back end. That's where most of the magic happens, right? And your front end is really just for presenting data. Now, most of the coding effort happens, most of our testing effort happens here. That's the core issue. What we try to do all of this business logic, try to validate all of this business logic from sitting here instead of trying it here. Tests are supposed to happen where your logic resides. A lot of code is back here, which is or should be the case, then most of your tests should happen here. To give this with an example, all your nasty bugs are going to be sitting down here. Trying to find it from up here. It's like mining a mountain, right? If you have minerals in a mountain, you don't try in from the top. You tunnel in into where you have the minerals, and you find the whatever minerals you want from there. Similarly, you have to tunnel in into exactly where your production code lives and where most of the risks are, instead of trying to do everything. Um, and now Mike Cohen, well, he gave different levels of tests that you can do. The ones which are more common are you would have unit tests, you would have integration tests, and you would have end-to-end tests. I've added a few more here. These would be more applicable for an enterprise level, but probably for complex applications which are really big, I think these levels would be these would definitely apply. All your back-end tests, back-end is going to be tested by your unit tests, tests, and by integration tests. And I'll explain unit component and integration in a minute. The beauty of these tests are they're low maintenance and fast to execute, and you'll spend less effort doing so, right? And I think most of us on the call know this. Writing tests or writing API tests or component tests or unit tests is very easy and very quick. If you haven't experienced it before, I can tell you from experience, API test is just so easy. It's just an API call, request response, specific JSON schema which you have to validate, and that is the end of it. A lot of flakiness which comes into with delays, finding objects, all of that. It's very quick. Time is very quick as well. I remember for a project, as a sample we tried doing a UI test, and it took us 7 minutes, just execution of the test. On an API was 300 milliseconds versus 7,000 You see the difference. And on the front end, what he said is you have high maintenance, high cost, slow execution. 90% of your test code should live here. That's the principle. Most of your tests should live at your back end, and very few of your tests should live on your front end. So automation focus is supposed to happen here. Is UI. So explained a test which was running in 300 milliseconds. Simpler, right? I just write a request, validate the response, get a request again, then validate a response, end of story. That's it. Why? Long process. Page, which make sure the page is loaded properly. Wait for all the objects. The object can why page a lot of time. So to fix all of it and to maintain all of it, you spend a lot of effort. So amount of people very less business logic if we stick with the front end. We still have all the tests to exploratory testing effort does not go down. Testing effort which has to be done because we weren't able to cover enough business logic. It's done right on the back end effort, you would be able to cover a lot of ground. Writing unit tests would be very easy. Tests and integration tests, they won't fail much. To execute, you will have very precise responses and you will cover a lot of business logic, which is the crux of the pyramid. Have your exploratory testing, which will have minimal effort. The most important key, which a lot of people miss, automating at this point. This diagram is, I think, the time where I'll spend the most time to explain these levels: unit, component, integration, system integration, and end-to-end. So let's get it, take this step by step. Method, right? And for that method, if you want to test something on that method, that's going to be a unit test, right? Of course, understandably. You have a class and you want to test across this class, be a unit test. In our shopping cart example again, if I take the total amount on my shopping cart that I just mentioned, the method, I would have a lot of different methods which would be implementing that specific piece of functionality in my backend, right? So for each of those, I would have a unit test saying, I would be using Mockito, for instance. I'll give some sample data, run the test. This is what the response is supposed to be. For instance, I have a function which is giving me the total value of my shopping cart. It computes the total sum of all the products. But response, I should know this is the total value I should get. You can have over a class. It's going to be a unit test, of course, understandably. Tests, it is something which is relatively not so very common. Now, example, Amazon.com, let's say, or a smaller application, I would have a lot of different endpoints. ECD. For instance, if I want to log in to my or to the website, I would have a different endpoint. Buy something endpoint. That would be a different Amazon.com/search, right? So all of these are different endpoints, and within each endpoint you have a module or class, and with classes and methods and all of that. Tests is where most of the negative tests you can do very, because again, your data, oh, by the way, I forgot to mention, tests are supposed to be mocked. Component tests are also supposed to be mocked. So any data that my endpoint needs, for instance, I'm fetching some data from a third party application, right? Whatever information is coming from the outside is supposed to be mocked. A lot of mocking tools you can use. One, there are a lot of others. So any input to my test is mocked, data to my endpoint, and I check the response. So that would be just like sending a post request and getting a response. The difference between component test and integration test. When I go across components, that's going to be integration test. Let me give you an example. In our case, where our total of the shopping cart, have a separate endpoint add to cart, and in the add to cart, this feature is being developed. My test, whatever I have to do for this total, will live in this specific endpoint, right? To check the flow of this, just one endpoint, right? I have to go across. I'll say login, add product 1, add product 2, add product 3, which are different endpoints, and then they'll say, okay, check the total. You go when your test is going through multiple endpoints, you have an integration test. Another very not so well known distinction between the two, tests which are running pre-deployment and pre-deployment. For a component test, usually not deployed, are not done when an application is deployed on a dev on a dev environment or staging environment. Host, just like unit test run, when the product is deployed somewhere, when the code is deployed somewhere, those unit tests are run. They're not done on deployment, they're pre-deployment. All I want is that one specific endpoint. It is being mocked. It's being mocked. The output I just checked. So I need to deploy it. I have a microservices architecture. Each endpoint is going to be a separate microservice, right? Microservice is going to be sitting behind a mesh gateway. All these tests are running on one microservice. Individual microservice, individual microservice, individual microservice. Integration tests, however, are run outside. So you have endpoints, then you have a mesh gateway. Gateway, you test your integration tests. Very key important difference. So you won't have login from inside the application. In test, you will have to log in because you'll have to pass through the mesh gateway. That would make more sense. Now we talked about, so all of this was just my back end, right? If I was in my application, of course, I would have a persistence layer, I have a database, I have my business layer, which we just checked, business layer, and then I have my presentation layer, which is my UI. Just running across all. As you can imagine, if I'm doing across my mesh gateway, then I am hitting all of these layers as well. Then is integration between my different layers of my application, but the layers, right? This is integration tests, and for most of the projects, that's where the story ends, because there's, if you have just one singular product. However, if your product is part of a larger ecosystem where you have a lot of different products, like this one product, you would have many products, 4, 5, and you won't want to test across all these products as well. Now, I define, and that's the mistake usually some people make. System integration test is where I am across products, stream one upstream, for example, right? For instance, let's say my shopping cart. Let's try to make an example out of it. So my shopping cart website again has some data. If I want to purchase something available on the site, I have the ability to search other shopping web cart sites. For instance, my team can search, let's say, the Raz. Goes back there, searches the Raz, calls their API, and gets okay. If they have the product, yes, there it's on that website, or will procure it with different product. So we can have front end integration with a different product. You can have front end integrations like the way we ask the Raz might ask us. So whatever is being integrated to the products, that's system integration. With very large enterprises, sometimes there is a very long chain of products which has which use. So for there, I call them customer journey tests. I'll use the word end-to-end because the end becomes the confusing. So customer journey test. A customer journey test is where if I want to complete one user flow, for instance, I am working on a banking, I have a banking application. I want to check or payment. On I log in, I look at my balance, I find the payment organization I want to do the payment for. For instance, it's a utility bill. Search for the response. Yay, done. So what me is on the scene. These might be 5, 6 different products. Thing is a customer journey. For me, that means the journey, right? So those are customer journey tests. Try to squeeze out in probably this. I know there was a lot to digest in this one, but it's really important just to give you guys the different layers of going back to our trial again. Integration tests across an endpoint, integration tests across outside of your mesh gateway, product, end-to-end integration tests of this exercise, where to test and how to test. Let me talk about the expectation. So our manager goes back to the Oracle, says, I haven't, you came up with all this plan, I haven't seen it. That was my prime motive to do all of this. And she goes, this is going to anything. Why are we doing this in the first place if it's not reducing cost? This is the key which people need to understand as to where really automation helps. So I'm going to give you an example of one team who don't have DevOps, more in a hybrid of waterfall agile-ish, which is most of the teams how they operate. And another team has more of DevOps practices. They have CI/CD pipelines built in, which take their release from a feature branch and they can deploy with single click to production. And let's see the difference. So for teams without DevOps practices, they would have most of their focus on exploratory testing, but it's mostly they have exploratory testing and they deploy environment to another. Their automation is on the back end, let's assume, more automated than doing exploratory ones, and their deployments are automated. Just with these three differences, let's see how this pans out. So in the time of how take to, let's say, one specific feature, the feature we talked about, let's talk about the same feature. Let's assume coding time for one time doing exploratory test for that specific feature, right? Time they'll take for regression, because if I check this feature, I don't know what else is broken, so I have to do regression, right? Which we don't get time for. For deployments, deployments which are manual again, all those merging problems you have, code merging in that, because most teams don't have single trunk deployment. Those deployment issues that takes time. The other team, let's say they take 12 days in coding, I mean testing automation code and other production code, right? So they spend time in coding. They would have less exploratory tests because most of their tests are done by automation. They would have less regression because some of it on the UI and depending on so let's say if the deployment is working fine or not. So what's going is with the team, then they spend time in testing, then they spend time they deploy. So of this time they have been spending. Earn anything. Once they deploy, earning. So you don't see the benefit or feedback of your feature unless it goes into production and it's in the hands of your user. Right? Most of their time is spent coding, a lot of time testing. I'm not saying they're not testing. They are testing. Quality time testing. The testers is not checking, right? And regression, most of it is being automated because they have a lot of backend work. And deployment is very easy. Deploying a new release is easy. Track a release is very easy. For them, coming up with a lot of different releases is not a problem. The hybrid model, they spend a lot of time in release, trying to release something. So they'll naturally say, you know what, we have to go through like 2-3 weeks of all of this overhead, so let's try to combine releases. Instead of doing a release 1 month, we'll do one release after 3 months. The team who have who are able to deploy quickly, they'll say, no, quickly, we'll try to release every 2 weeks. If something goes wrong, we can roll back, try to deploy as quickly as we can. This is the core difference, which really then makes teams stand out. And I'm going to give you a real example of what happened. There was a team, a company I worked with a long time ago. Small company, just 2 rooms, a lot of experience in building the product. They started building. It was a rail locomotive automation product. Building that product, very basic feature, and they rolled it out, right? And then their customers came back and they used the small feature and they said, yeah, this is good. Okay, can you build this for us? And they say, okay, yeah, sure, we can build it for you, but that will cost you. All right, you have to pay me for it and I'll build it for you, no problem. They build it. And there was another company, so sorry, for these guys, they would spend and they would get return from the market immediately. Something again, build a feature and get return from the market immediately. Cash, because their investment wasn't that big. Money, getting feedback, improving their product at the same time. Company in another part of the world, which was a very big setup, had 20 years of experience building the same product, but exactly same product. Philosophy was, will not release until the product is 100% perfect. We have to make sure that the product is extremely good. Was they spent a lot of time improving the product back from the industry, any money. Spend, and they would get a little bit of return. Spend, then return. Longer term, what happened? 2 room of a two-room company, small setup. They went and bought this whole big setup because they had a lot of cash, and these people were in trouble because they didn't have a lot of investment. They've spent all their investment. They were in financial crisis. The power of delivering quickly is what really makes the difference. Is and this is why managers are really curious about, or really looking forward to reducing their time to market. Market it is, well, first movers advantage. For example, let me give you a good one. Right, the whole world is affected. That comes out with a vaccine is going to win by far. And there is a massive race between the pharmaceutical industry trying to come up with who comes first up with, clears all the clinical trials, human trials, and they're able to productionize that vaccine. Whoever comes first is going to take over. Goals of automation should be develop a test mindset by the whole team. It's not an individual person's job. Spend times thinking, help checking. So once we've thought what has to be done, you get a machine to do it. Have a new feature, you do the risk analysis with the developer, we discuss, we find few things, and we say, okay, so these are the few things we check. These are the kind of tests we should have. Okay, Mr. Developer, you write these on the unit and component level. I'll write these on the integration level. Piece we'll try to add to one UI test which we already exist. We'll just add one more step, and that is it. Have time to market. Your ability to deliver quickly. You would be able to release quicker. You won't have the problem of, oh, wait, before each release everyone wants to put their hot fix in there. Because if my feature does not get into this release, it will be another 3 months before I get a chance. Releasing on a regular cadence, no one has a problem, because if it doesn't make this release, no problem, we'll do it after 2 weeks, fine. Right? Time to market. Improved quality. Say this, quality is a relative term. For another person, quality, each person has a different definition of quality. Are Japanese cars of higher quality, or for a lot of people, German cars are quality? I would argue Japanese cars are easy to maintain, and it's their parts are very cheap. I think that's a higher quality. For my definition of quality is I don't have to spend a lot of money to maintain it. Definition of quality. For another guy, he would say, no. Quality is only comfort and feature set. Definition of quality is different for everyone. That's why it's important in the customer's hands, and then they would tell you what your quality is, right? So you need to set the right expectations. These are the 4 goals which an automation project should be looking for. I don't think we have time to read. Thank you for attending. You can find me on social media.